Hi everyone, you're watching the 3.12 lesson video on linear applications day 2. So we're just continuing what we were talking about yesterday, or whatever, maybe it wasn't yesterday, but the previous lesson. In the previous lesson, we were talking a lot about slope-intercept form and how that was really a nice way to help us take words or graphs and put them into equations. Today, we're going to see something a little bit different. But one thing that I wanted to start out the video with is talking about how to translate just some of the basic lingo, because we're going to deal with inequalities and equations today. So number 1 says half of x is at most 5 less than y. So let's turn this into some algebra. So half of x is at most. So at most, a lot of people think it's greater than or equal to because they see most and they think that. But if you think about it and give yourself a little bit of a real life context, like you have to be at most 20 pounds to ride on this ride. I mean, 20 pounds is actually really light, so maybe something more like 50 pounds. I don't know. What that actually means is you can't be any more than that. Like you actually have to be less than that amount. So at most is less than or equal to. So always be careful of that. And then 5 less than y means we're taking 5 away from y. So y minus 5. If we put this all together, our inequality will look like half of x is less than or equal to y minus 5. All right, let's do the same for number 2. 2 more than y means we're adding 2 onto y. So it's very similar to the 5 less than y that we saw above here, only we're adding 2 is at least. This is the opposite. So that has to be at least. So that or more triple x. Triple x means we're multiplying 3 times x, like triplets. There's 3 of them. So y plus 2 is greater than or equal to 3x. Okay, so there's some inequality language that I think is going to be really helpful with today. All right, so question number 3. This is our last question on this. And it says the senior class at Hilton High is planning their annual trip to New York City. Each bus can carry 24 students and each van can hold 12 students. There will be at most, ding, 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 there's that key word or those key words, 192 seniors. All right, so if there can only be at most 192 seniors, that means that there's 192 seniors or less. So less than or equal to 192. All right, so A, no surprise here, write an inequality. Well, we just talked about the at most. So we need to write an inequality that's going to model this. So if we wanted to, we could definitely set up a table of values. But the really nice part here is if we look at our graph, we can see the number of vans is our y value and the number of buses is our x value. So if we look up top here, each bus can carry 24 students. So however many buses we have, if we multiply 24 times that, we're going to figure out the total number of students that can be on there. Or sorry, total number of buses that we can have. So the x. Okay. And then the vans. Okay, same thing. So each van can hold 12 students. So that would be 12y. If we add those two values together, that's going to tell us the total amount of students now, because we're multiplying 24 times the number of buses plus 12 times the y, the number of vans. So that's a bunch of students. And we know that that number of students has to be less than or equal to 192. Okay, so at this point, we have a few options. We could solve for y, or we could graph this and generate our table of values that way. I'm going to use my calculator just because I think a lot of us this year really have wanted extra help with the calculator. But maybe if we have enough time at the end of the video, I'll go back and show you how to solve for y. So we're going to add a graph. We need to add in a relation because we don't have it in slope-intercept form. And I'm going to graph 24x plus 12y is control equals, gives us our symbols, less than or equal to 192. Please, I can't stress this enough, do this on your calculator with me. Do not just watch me do it, because you're going to come to class and you're going to be like, I don't know how to do it. But if you do follow along, it's going to get ingrained in your brain a little bit better. So do yourself a favor and do this along with me. Plus, using your calculator is so fun. Okay, I'm going to hit enter. Ooh, interesting. Well, here's the deal. I see my x-intercept, but I don't see my y-intercept. So I'm going to use my tracing tool. So menu, we've done this before. Trace step, I'm going to change it to 1 so I don't see any yucky decimals. Then I'm going to go menu, trace it again, and I'm going to do graph trace. And the cool part about this is it's immediately bringing me up to the point 016. And then let's just use all of our nice points. So 016, 114, 212. All right, let's write these all down. So 016, so this is my x and my y. So 016, we said 114, we said 212. And I think you guys right now are noticing that pattern, 310, 48, okay, so on and so forth. So as my x's increase by 1, my y's are going down by 2. I'm just going to finish this off so that way we have a complete table so we can see both our x and y intercept. Some of you might be saying, oh, the slope is 2. Yes, you are right. Okay, so we have to go all the way up to 16 with our y-axis and all the way out to 8 with our x-axis. So to me, I don't think that we need to change our scale. So let's plot, let's see if we can go up 16. So this is 2, 4, 6, 8, 10, 12, 14, 16. Okay, cool. So we can plot that first. Sometimes we might have to change our scale, but we didn't in this problem. And you know what? Let's just leave this as a scale of 1 as well. So 2, 4, 6 every 2, 6, 8. I think this is going to be okay. We'll cover enough of the graph. If you wanted to, we could stretch this out to be a little bit longer on the x-axis and saying that each graph mark was worth a half, but let's keep it simple for today. Okay, so 016, 1, 14, 2, and we're just going to keep following this pattern all the way to the bottom of the graph at my y-intercept of 8. Let's be mindful. Should this line be solid or dashed? Well, it's solid because it's equal to, less than or equal to. And we also need to shade, and we're going to shade below. And we will use our calculator to help us with this. So we were shading underneath here. Okay, and if we want to keep going down, we can see the rest of the points just to see this is my x-axis and my y-axis. Here's my origin right here, and we can see the shading is underneath. Some of you are like, oh, you know, Mrs. Ruscio, label that inequality, and you are correct. We should. Okay, then part B says state one possible combination of buses and vans needed for the trip. So basically, you have tons of points to pick from. Because it's a solid line, we could pick anything on the line, and we could also pick anything in the shaded area. So it's entirely up to you. I'm feeling like I like this point right here, which is a 0.54. Now, I'm going to write that down. But this would not get me full credit because I did not state how many buses and how many vans. So we need to be specific. 5 buses, because that's my x value, and 4 Vans. But like I said, there could be lots of different ways that you could write that. I had originally said that, I don't know how long I've been recording this for, but I feel like I'm getting close to the 10-minute mark. So I'm not going to solve this for y, but instead of using this graphing feature, what you could have done is gotten y alone by subtracting the 24 from both sides, or 24x, I should say, from both sides, and dividing by 12. And then you would have gotten y is less than or equal to, what would it be, 2x? Oh yeah, I think before I said 1/2. The slope is not 1/2. The slope is 2, silly Mrs. Ruscio. Sorry, that was a mistake that I think I said it earlier in the video when I was talking about the table. So the slope is 2/1. So this inequality would be y is less than or equal to 2x, and then our y-intercept was what? 16. So 2x plus 16.